Last time, I tried to figure out how to build boxes out of wooden planks. I was able to duplicate some boxes that I was lucky enough to have a more or less complete setup for making, but when I tried making boxes of different sizes, things didn't go as well. I'm not sure what it is I'm doing wrong here, but after all, some months ago I forgot all of math, so this is likely another thing that I'm gonna have to rebuild from scratch. Today, I want to try and figure out what's going on by starting with something simpler and working my way up. Rather than boards and boxes, I'll start out by thinking about lines and squares. For the record, while I've forgotten all of math, I do still seem to know what shapes are, more or less. A square is a shape that looks like this. I suppose it would have to have four sides. This wouldn't be a square after all, nor would this. And this isn't a square either. I'd say this is a rectangle. The difference has to do with the lengths of the sides. Both a rectangle and a square have four sides, but a square specifically has all four the same length. So let's try building some squares. I'll draw four lines, each 1 inch long. This is a little trickier than I thought. I'll try again. Still no luck. I wonder what I'm doing wrong. Once more. Okay, now we're getting somewhere. Still, looking at this, I don't really think I'd call this a square either. Sure, it has four sides, and they're all the same length, but I wouldn't say it's the same shape as this. There's something different about these two shapes, and there's also something about drawing a square that's proven weirdly difficult. Let me try looking at something a little different. I've got a bunch of this paper with a lot of little squares on it. The squares completely fill up the paper, there isn't any space between them. If I try drawing a square on this, yes, it seems like this is working. Something about lining up the lines I draw with the squares on the paper seems to make drawing a square easier. It's not just the side lengths that are important, there's also the angle the sides have to have relative to each other. I can measure the length of sides, but I'm not sure how I'd go about measuring angles. I can copy an angle by tracing over it, but I imagine that's not always going to be convenient to do. I wonder if there's a way to figure out what specific angle it is that I need to make a square, and to build it without having to copy it from somewhere else. Maybe this is somewhere I can start. If I try to recreate one part of that grid of squares on a blank piece of paper, well, clearly I've not done a great job here. But maybe comparing this to the grid and seeing how they're different can tell me something. It looks like a bunch of the lines that I drew have angles that are too big on one side and too small on the other. I wonder, let me try something. Okay, I've got some thin, straight sticks now. I can use them like the lines I draw, but this way I can try moving them around. Let me look at just one of these corners, where four of the squares on the grid come together. I can try spinning one of these sticks around this corner, going through all the angles it can go through. And it seems like my hunch was right. No matter how I spin this stick around, I think the angles this stick makes to the drawn line have to follow certain conditions. It looks like these two angles are always going to be the same, and so are these two. And also, like if this angle is too small, then this one would have to be too large and vice versa. If I'm right about this, then the angle that I need to make a square would have to be exactly in the middle. These four angles would all have to be the same. It's important to note, I haven't tried to prove anything about angles or shapes just yet. These are just observations that I'm making. I can make guesses based on these observations, but until I've proven them, the most I can do is to experiment and see if my guesses match up with reality. Let's try building a square using this guess. I can figure out the right angle to use, by that same method I just tried, and try drawing 4 sides that are all the same length. Indeed, this seems to have worked. This is a very good sign, but still isn't proof of anything. How do I get from where I am now to being able to prove things about angles and shapes? Let me think about what I did when I came up with numbers. I started off just by thinking about counting objects. 1 apple, 2 apples, 3 apples, and so on. I looked at how counting objects worked and came up with numbers as a way to model counting objects. The turning point was when I realized that I could build a definition for numbers that didn't itself rely on counting anything. That way, I could prove things about using numbers using that definition, and know that they'd be true no matter what I was using numbers for. What would the equivalent process be here? I'm looking at drawing shapes on paper. Well, there's one idea. I talk about drawing lines on the paper, but of course, what I'm literally doing is very precisely spilling ink on it, coloring part of it in. I could draw lines in other ways, by rubbing graphite on it, depositing a layer of differently colored material, for example. So maybe I can start with lines as a more abstract concept and see where that gets me. I can draw lines in a bunch of different ways, and those lines can all come out looking very different. I don't usually think about it, but pretty much all drawn lines have some amount of thickness to them, which may or may not be consistent. I guess that suggests that a more abstract idea of a line shouldn't care about thickness. Although, I can also draw lines of different lengths. So does that mean the abstract idea of line shouldn't care about length either? That feels like more of a stretch. And of course, straight lines aren't the only things I can draw. I can draw curved lines, shapes, just dots. Actually, that last one gives me an idea. Part of the idea behind numbers is that you shouldn't be able to split them up any further. The only way to have less than 1 apple is to have no apples. I can draw shapes by combining a bunch of lines together, and I could draw a line by drawing a whole ton of tiny dots in a row, although it would take forever. But there isn't any less drawing I can do than drawing just one dot. Of course, it's still true that I can draw a dot in a bunch of different ways. The dot I get will be slightly different depending on if I use a pen, a pencil, a marker, but this feels a lot easier to get a handle on than the case with lines. Take a marker, for example. I could draw a dot by lightly touching the surface of the paper, or by pressing down hard. The former dot is clearly smaller, and I could get just about the same result as the larger dot by making a bunch of the smaller dot. The sharper the marker I use, the smaller the dot I can make. If I had a theoretically perfect marker that was perfectly sharp, the dot would just be the point at the end of the marker. This feels like a good candidate for the abstract thing I can use to model drawing. A point. Now, how exactly could I go about defining what a point is? I guess in a way, a point is pretty much just designating a particular place on the paper. When I draw a dot, what I'm doing is effectively just moving whatever drawing tool I'm using to the place specified by a point, and pressing it down there. What would that mean for lines, though? I had the idea that I could draw a line by drawing a whole bunch of dots, but as the dots get smaller and smaller, the number of them I'd need to draw a line would get bigger and bigger. I'm not quite sure how to deal with this for now. Let me start with points, and see what thinking about points gets me. Suppose I have a point picked out on a piece of paper. What can I do with that? Well, there's not a whole lot. So, say that I have 2 points. Now there's something. I can draw a line connecting the 2 points. But, There are a lot of ways that I could draw lines between the points, but there's one that feels special somehow. There's only one way to draw a straight line between the points. Maybe this can be a way to define what a line could be, in terms of 2 points. Maybe I can think about it this way. If I'm starting just with points, and forget about measuring and shapes and all that, what can I build up? I can mark points on the paper, and I can draw straight lines between them. I guess I could also fold the paper or copy sections of it from one place to another, but those both feel a bit like cheating. I don't know if there's anything else I can do without using some kind of external tool, or manipulating the paper itself in some way. And to be fair, to really make sure that I'm drawing an actually straight line, I'd need some kind of straight edge to draw against. That said, I do have something kind of like a definition for a straight line in this context that works without relying on any external tools. I only need the tools to physically draw it, and connect that abstract idea of a line to an actual drawn line on a sheet of paper. Is there anything else like this that I can think of? If I have 2 points, I can pick one of them and make it the center of a circle, with the other being on the outside. I know what a point is and a straight line, so what's a circle? Breaking out the meter stick, it looks like a circle is a shape which is the same distance across all the way around. I guess that makes sense. Wheels are circles, after all, and they're made so that things can roll on them without bouncing around. Adding in circles feels like it would give me a lot more to work with. Starting with 2 points, and the line between them, there's not much I can do. But if I draw 2 circles, each one centered on one of the 2 points, now I have 2 more points that I can do things with. In fact, if I draw another line connecting the 2 new points, it looks like I get that angle that I needed to be able to draw squares. Testing it out sure seems to work, but again, I haven't really proven anything just yet. Still, this feels like I'm going in the right direction. I may not quite be able to prove anything about shapes and drawing yet, but I'm pretty sure I'm on the right track.